Welcome. By now, I'm sure you've heard of generative AI and LLMs, but how do we get here and how can we continue on safely? So first of all, we're going to wade through an alphabet soup of jargon. We'll focus on LLMs, which stand for large language models. So what are language models and how they get so large? We'll get a sense of how all these pieces fit together. And language models, well, are part of NLP or natural language processing. And that's what I originally studied as a computational linguist in ancient times. The holy grail in NLP is to talk to computers like any other person. No need to learn computer languages because they can speak ours. When I first started, linguists would created these expert systems by hand coding like zillions of grammar rules and all these vocabulary. Excruciatingly mind-numbing work. The results were mediocre. Then came statistics. How does that work? You shall know a word by the company it keeps. So this simple idea was profound. If you start counting words and look at what other words are around it, you learn tons about the language. Those relationships make up the language model. Think about learning languages as children. You're immersed with the sounds and sentences. You know what sounds right and wrong, even if you don't know why. You've internalized the statistics of your language model. So how did we go from mediocre to, oh my gosh, we can't even tell what's AI generated? Well, I've only got 10 minutes, so I'm going to skip to GPT, which stands for generative pre-trained, and the T is transformers. Now that's a special kind of neural network introduced by Google in 2017. But before transformers, language models were kind of slow and forgetful, like the sweet granny, just struggling and getting confused with all those long sentences. If you gave her even more, like, so past models, if they got bigger or trained on more data, it just didn't improve much until transformers came along with their attention mechanism. And now models could look at everything all at once. Long-term memory, no problem. Give it Wikipedia, piles of books. The models just kept improving. They're super data hungry and need tons of it. So throw it, the whole web at it, blogs, tweets, code, whatever. Another problem is all models processed sequentially, one word at a time. But transformers could process things in parallel and zip through it all. So models got bigger, running faster, and trained on more data, and the performance just kept getting better. Now I'm going to skim through this transformer diagram with an encoder and decoder. One side on each side, some variants with an encoder only or a decoder only. So language models have been around for a while, but what makes them large? The size of is measured by the number of parameters or neurons. To be considered large, models usually have at least 1 billion neurons. Now, it's not quite the same, but for reference, the human brain has about 85 billion neurons. And they're usually trained on either like a fill in the blank or a next word prediction. So let's play a game. Go grab a book, pick a sentence, and give the first few words to the model, and it tries to guess the next word in your sentence. You show it the actual word, okay, it updates the neurons to better guess next time. So you keep guessing, updating until the model gets really good at this. Like twinkle, twinkle, little like star should be next, right? Might feel like a fancy autocomplete. But think about talking to someone who completes your sentences. That's supposed to be a sign of deep mutual understanding, right? The computer. Mm. So back to GPT. The P is for pre-trained. What's that? In the past, we trained a bunch of models as specialists, like answering questions, classifying things, or translation. But GPT is a generalist, pre-trained to understand human languages in general. These base models are huge, cost millions to train over months. So you really need deep pockets, and it's not for everyone. The pre-trained base models can be fine-tuned for specific tasks like, well, LLMs have been out for years. Right? GPT-3 was released in GPT-3 was released in 2020, and ChatGPT was just a tweak off the base model released 3 years ago. So why did it suddenly go viral last year? The secret sauce is this RLHF, or reinforcement learning from human feedback. So remember that next word prediction game? Well, it's great for learning language, but not so helpful when talking to people. I mean, you don't begin a sentence and expect someone to guess your next word. So GPT-3 was fine-tuned to respond to instructions. And this additional training was actually quick and cheap compared to the pre-training the base model. And that brought out some skills that had been hidden in the base model. It was also fine-tuned on back and forth dialogues, and suddenly following instructions, carrying on conversations were super helpful and really eerily human. Okay, so what's next? Well, multimodality will allow LLMs to go beyond text and sort of see and hear. Open sourced LLMs are smaller and cheaper, but still powerful. And agents are programs using LLMs to plan and execute plans. So, exciting stuff, but a little worrisome, which brings us to the small and growing field of AI safety. AI is getting more powerful and it's actually faster than expected. So, mitigating the risk of extinction from AI should be a global priority alongside other societal scale risks such as pandemics and nuclear war. Whoa, are these Luddites or cult-like doomers? This 22-word statement was signed by the pioneers of deep learning and leaders from the top AI labs, including Google's DeepMind. When the people creating the technology are concerned, what should we do? Well, some smart people are attacking this from like multiple angles. So, for example, RLHF that made GPT so useful. That's research from OpenAI's alignment team. And the AI alignment is a subfield of AI safety to ensure that AI is aligned with human values. Now, another approach is to evaluate LLM output, like inverse scaling laws. So usually models kind of get bigger and better, but this project found a bunch of examples where the bigger models fail. Something to be aware of, right? So the models can also take input and magically generate an answer, but you have no idea why. Mechanistic interpretability sort of reverse engineers the models to understand the internals. It's like neuroscientists dream to like peel open the brain and study the neurons in action. So removing that magic and truly understanding the why and the how, super fascinating. So that's some promising research out there, but for each person working in AI safety, there's 300 more that's making AI more capable faster, and that gap is only widening. So we need help. We need engineers, designers, communicators, and more. If you know AI or ML, perfect. If not, you can learn, make a difference. So here are some resources to get you started. This is the dawn of a new era driven by AI. the potential benefits to humans is huge. There's also a definite non-zero chance that things can go really, really badly. So it's crucial to have diverse voices shaping this AI-driven future. So we need to be informed and involved in the decisions that's going to impact all of us. My hope is that we can be guided by wisdom and empathy and a commitment to embrace the power of AI safely. Thank you.